Hello viewers, in this session we will learn about AI vector search. So the agenda for today's session is what is vector database and AI vector search, its use cases, why it is getting more popular, and next steps, what is new with Oracle AI vector search. So most of the data which we see analyzed today in real time real world is unstructured data. Unstructured data is nothing but images. It would be images, videos, documents, etc., etc., and a lot more. So, but for human beings, it is easy to identify and interpret the unstructured data, but for in case of computers, to analyze these unstructured data, it has to be converted to numerical formats such as zeros or ones. So first, let's know about these terms: vector, vector database, and then vector embeddings. So first, let's know what is a vector. A vector is a numerical representation of unstructured data, uh, where the unstructured data can be images, videos, documents, etc. So what happens whenever we give this unstructured data, this can be a document, video, and this can be an audio file. So these are the unstructured data. These will be converted as a vector format. So this is nothing but the vector representation. So this is all the unstructured data, and this is the vector format. So this is the unstructured data. This is a vector. So now you are able to know what is unstructured data and what is a vector. So now let's see how can we convert these unstructured data into the vector representation. So there will be lot of vector embedding models. These are the vector embeddings are nothing but these are the models, machine learning algorithm models, which will be converting these unstructured data into the numerical format, or that is vector representation. So there are multiple types of vector embedding models. Uh, they for each type of unstructured data, we have some different vector embedding model. For example, if you are using a Word document, there is a Word embedding model, that is Word to Wake or Glow or for text embedding models, etc. For documents, we have some different embedding models, and for media files, we have some different embedding models, and for images, we have some different embedding models, like like a CNN model and so on. So this is all about the embedding models. So there will be some complex machine learning algorithms which will complex working behind to convert these unstructured data into the vector representation. So, but for an end user, it's just unstructured data is converted into the numerical representation. So the important point here is it uses different algorithm for different unstructured data, type of the unstructured data. So this is all about vector, the unstructured data and vector. So now at this moment we have unstructured data that is getting that has got converted into the vector representation, and now we have the data. So now we need a place where we have to store these data vector. So that is called a vector database. So this is the place where we store vector database. So now we have vectors, vector embeddings, So now we need a place to store these vectors. So that is where we use it as we store it in the place of vector database. So the vector database is designed to store and process the data in a very optimized manner, and it also gives the environment to do all the analysis on these vectors. So now we have vectors, vector database. We have vectors. We have also vector database to store these vectors. So now we need a mechanism to perform operations on these vectors. So that's where it comes into the picture. Vector search comes into the picture. Vector search. Yeah. Vector search is a way to get the value out of the vectors. So this allows this vector search allows you to ask questions into the unstructured data and get the relevant answers back. So now we from at here we are able to understand what is vector, what is a vector embedding model, and what is vector database, and what is vector search. So now let's go with an example to understand in more detail. So let's consider a house, image of an house. So which we are going to consider convert this image into the vector representation. So how this is internally it converts into the a vector representation. So for a house, we have different types of attributes or properties, features. So those are this is a house. So for house, we have different type of representation features, and that is suppose the type of roof. The type of roof and the type of decoration. And the type of building material. So etc. These are different types of properties features will be having for the house. Whether it is the type of roof, the type of decoration, building material, and so on. And this. So for each and every feature, it will generate a numerical representation. So suppose the roof will be represented with 32, decoration will be represented with 46, and this will be 64. So in the same way, each and every property of this house will be converted into a numerical value. Here in this image, in the vector representation, 32 represents the type of roof of this image. 46 represents the decoration of the house, and numerical represents 64 represents the type of building material. So this is how it will be representing the numerical format of the house vector representation. So now you are able to understand the vector conversion, like how the numerical unstructured data is getting into converted to the numerical representation. So now let's talk about the use cases where we use vector search. So if you see about the use cases, it is mostly it is used in most of the industries in the real time, such as e-commerce. In e-commerce, for example, if we talk about recommendation engines, like when you watch a movie in the Netflix or Amazon Prime, you can get a next best type of suggestion depending on the movie that you are watching, and that depends upon the similarity research with your previous watching. Suppose if you watch few movies, then automatically it will recommend or suggest some movies which are based on your previous watch history. So that is where the vector search is used to improve the customer satisfaction, and also it is used in most of the e-commerce applications like Amazon, Netflix, Amazon, Flipkart, and other e-commerce applications where you can upload a product, a, a picture of the product, and you can search using the product so that it will internally the process it will do this vector search, and it will recommend the similar products you are looking for, and making the search easy. So it is also used in NLP, natural language processing. Suppose imagine a large organization receiving high volume of customer support tickets through various channels such as chat, email, social media, and the routing of these tickets effectively to the appropriate support teams will be very critical, in maintaining and also maintaining the customer satisfaction and response time is very difficult. So in this area, Oracle AI Vector Search continuously learn from the incoming tickets and feedback by you, and also feedback, and it will improve its accuracy over time by routing the correct ticket to the correct team so that the customer ticket will be resolved easily, and the customer satisfaction will be improved. And then coming to anomaly detection. So when coming to the anomaly detection, in today's world, the network security is the most important for any organization. Anomaly detection plays a important role in identifying, mitigating any potential threats to the network infrastructure and data. So Oracle AI Vector Search in this area, right, it will enable organizations to enhance the network security by monitoring and detecting any threats in the real time, and safeguard the digital assets and sensitive information effectively. So, and coming to the geographical, there are other applications also like geographical applications, geospatial applications. So here AI vector search can enhance the disaster response efforts by analyzing the geographical data such as satellite images, aerial photographs, sensor data, and in this in this area, like each geographic feature, like earlier we discussed, for a house we have two type of roof decoration, and so on. We have it will convert each feature as a numerical value. So in this case, it is convert, like we have geography features such as roads, buildings, water bodies, which can be these features can be converted into the vector representation, and it can do the analysis of the images and all, depending on the on these patterns. It will do the similarity search, or vector. It will perform the vector search operation, and it can detect any geographical data or disaster response by analyzing these images and other data. So, and it can also be used in genomics and biometrics, bioinformatics, where be like bioinformatics, it can be used. So in this area, like we are getting like we in this we are able to we are seeing lot of diseases or any other like viral infections very popular. So in this area, and a vast amount of biological data are generated and analyzed to understand different variations, genetic variations, molecular interactions, biological process. So in this area, Oracle AI Vector Search can assist in variant annotation and interpretation by transforming these diverse data resources into the vector representation. So this is and there are many more use cases use cases, scenarios where we can use vector search. So now let's see, like this AI vector, the Oracle AI vector search also allows interaction with LLMs. So what is LLM? LLM it also allows interaction with LLMs. LLMs are nothing but large language models trained on massive amount of data that can use it to generate and translate text and content, and also perform other some NLP, natural language processing tasks. These LLMs are used as a way for a variety of NLP tasks such as text generation, machine translation, text summarization, question and answering, chatbots that can hold with human humans. So this AI vector sets allows interaction with LLMs, but the main problem with LLMs are there are a few concerns by using with the LLM that are like these as these LLMs are trained on snapshot data that doesn't have the real-time data or private data. So there is a concern about the ethical use of LLMs, especially in generating false information or any deepfake or harmful content. And these LLMs are also also may memorize the sensitive information from the training data, raising privacy concerns. Uh, Suppose a few examples are like hallucination, and it's hallucination concerns of LLMs. Hallucination. So hallucination is essentially when a large language model has a question asked, but it doesn't. If it doesn't know the answer, it just alerts out an answer. Uh, and for customers as end users, how do they trust the answer coming from an LLM? Especially when your customers are going to take any decision coming from this LLM, and if that decision has went wrong, and that if that decision has made any large amount of loss, that will be a very situation, where you cannot blame anyone. At the end of the day, it's a robot giving you an answer. So we can. This is a major problem with uh, uh, LLM. So here we can build trust in the answers which we give, we get from LLM using a using technique called RAG. RAG. So RAG is nothing but retrieval argument language. It's also a LLM model. So here when we use RAG technique, the job of the vector database is essentially to help with the LLM model by providing private business documents. So, for example, if I want to ask a question to my business about my business to my LLM, I know the data is coming from my private business document. Private business documents. So I know the source of the data coming when I use this RAG. I know the source of the data from where it is coming from, and where the answers are coming from, and where the LLM is going to analyze these questions and answering. So in this, as an end user, I am confident that the results I am getting are actually from a business data, and they are not just coming from any random place on the internet. So let's say if I have a question, how do I solve an Aura error? And what I do is take that question and convert it to a vector format, that is numerical representation, and pass it to the database. So the database will search through all the other data or documents that I have stored, and will find the closest match of resolving a Dora error. So as we discussed earlier, the things that have a similar vector representation will be stored close to each other, and that have a different representation are stored far away from each other. So essentially, a search will be done in the vector database, and the documents which are closely matching my Aura error will be picked up, and the top 2 to 3 documents that can be answered the question will be displayed. So instead of the LLM trying to answer it on its own, we take those documents that are returned and pass it to the LLM, and we say to the LLM, answer this question. How do answer this question? How do I solve this error from these documents? So these documents are the one we know that can be trusted because they are coming from our internal assets or internal business documents, and it's able to search for that answer in those documents and return it to the end users. And so, you can see that the vector database is acting as the source of trust in this scenario. So, so the vector database, vector search, the Oracle AI vector search capabilities are announced from the with the Oracle database 23.4. With the release 23.4. So we are not earlier when you want to use the vector capabilities, you need to have two databases. One is relational database and the other is vector database. So and the developers and the administrators are used to sync up these both the databases periodically. So there is a dependency in maintaining the two databases, and it is very complex to keep on monitoring this the replication and the databases each other. So to resolve this issue, Oracle has come up with the Oracle AI vector search, which is integrated with the relational database. So now in Oracle 23 AI, it supports relational search, and similarity search. So now we don't need to have these two databases. We can only manage the relational search, also the vector search using single database. So that is the reason we call this as 23.4 as converged database. Converged database. So here, the regardless of which database you are using, which workflow type you are using, which data you are inputting, we have only one place, that is Oracle 23 AI, a database where you can store different types of data, whether it's structured data, unstructured data, spatial data, JSON data, whatever the data you want, you can store all this data in one place. So to achieve this, to support this or to achieve this mechanism, the Oracle has introduced a few new data type indexes in the Oracle AI 23.4, 23. So what are the different introduced? It has introduced a data type, different data type, which is vector data type. Vector data type. So vector data type, and it also introduced vector indexes. It also introduced a few vector functions like to underscore vector, from underscore vector, and so a lot of functions it also introduced, and it also introduced embedding models like vector functions like vector underscore embedding. So there are a lot of functions it introduced to achieve this. And it also introduced a new pool called vector pool in the SGA, shared memory area. Shared SGA in SGA, it introduced a new pool called along with the shade pool, buffer pool, and all. Along with the shade pool, buffer pool, regular buffer, and everything, it also introduced a new pool called vector pool. So, what is the purpose of this pool? The vector pool is nothing but it's a pool used to create indexes. To create any index, you need to configure this vector pool. Vector pool. To allow vector connection, so how can you define this pool? You have a parameter called vector underscore memory underscore size. Vector underscore memory underscore size. So this parameter controls the size of this vector pool. So and also vector Oracle AI vector search with this Oracle 23 introduced two different types of indexes. Those are in-memory index, in-memory neighbor graph index, and neighbor partition vector index. Partition vector index. So these in-memory, you have hierarchical navigable HNSW indexes that are the only type of in-memory HNSW. That are the only type of in-memory indexes which are supported for graph type of applications. And for any and these IBF inverted flat file index of this neighbor partition index are supported for partition based indexes objects to improve the search quality and with a reasonable amount of speed. So now let's see the workflow of vector search. So the workflow is first generate the vector embeddings, then store the vector, so store the vectors in vector database, then create indexes on these vectors to improve the performance and speed, and then apply the search operation, search and other functions on this vector data. So this is the workflow of vector search. So this is all about vector search. So now with these features you can do relational search as well as semantic search using vector search. So now if you want to create any table using vector data, you have to create a table like this. Create create table name, and then again the column name and suppose house number, house ID number, and like city, varchar, house vector. Here we need to define the data type as vector for vector column. So here I can define vector house number as vector. House number as vector. This means it supports multiple dimensions and multiple data formats. So the vector it supports this column supports integer value, int 8 value, float 16, float 32. These are the storage format it supports. So now defining the vector column, we can define the vector column as column name. Suppose house for house vector, if you see, and the data type as vector, like this. So this is equivalent to, without mentioning anything, vector. So here we have two fields. So this is the number of dimensions, and this is the storage format, whether it is int, float, or any other. So this is how we have to define the column of the vector. Suppose if you want to have a two-dimensional vector with integer storage format, you have to define like this: vector of dimensions are 2, storage format is int 8. So this is how you have to define. If you define the vector called data type as like this, it will support only two-dimensional vectors and integer storage format. If you define this way, it will support all the dimensions, whether it is 2-dimensional, 3-dimensional, 4-dimensional. It will support every dimension and multi-dimensional as well as multi-storage formats. So if you want 3-dimension and as storage as float, you have to mention 3 dimensions, comma float 32 or 62, whatever you want. So this is all about vector search. So how you perform the search on this vector search? So we can select the table with the vector distance function. So the query should be, you have to use vector distance function to perform the operation on vector table column. So it will be like select star from table name where house. Suppose if we have house vector where house number equal to something and order by vector name, vector column, house vector sorry, here you have to give vector distance function defined vector underscore distance house vector column name space input vector. So it will perform the search operation on this vector column. So this is how we have to define the perform the search operation, select operation on vector function, vector column. So this is all about Oracle AI vector search. Thank you for watching this session.